1. Finding the middle element of a linked list in a single pass. Approach: use two pointers, a slow pointer and a fast pointer. Move the slow pointer one node at a time and the fast pointer two nodes at a time. When the fast pointer reaches the end of the list, the slow pointer will be at the middle. Steps: initialize two pointers, slow_ptr and fast_ptr, and set them to point to the head of the linked list. Traverse the list. In each step, increment slow_ptr by one node and fast_ptr by two nodes. When fast_ptr reaches the end of the list, slow_ptr will be pointing to the middle element. 2. Implementing a queue using stacks in C++. Approach: use two stacks, S1 and S2. For enqueue operation, push elements into S1. For dequeue operation, if S2 is empty, pop all elements from S1 and push them into S2, then pop the top of S2. Steps: enqueue, x push x to S1. Dequeue: if both S1 and S2 are empty, return an error. If S2 is empty, while S1 is not empty, pop an element from S1 and push it to S2. Pop the top element from S2. 3. Finding the common ancestor of two nodes in a binary tree. Approach: start from the root and traverse the tree. If both nodes are on the left, move to the left subtree. If both are on the right, move to the right subtree. When one node is on the left and the other is on the right, you have found the lowest common ancestor. Steps: start from the root node. If both nodes are smaller than the root, move to the left subtree. If both nodes are larger than the root, move to the right subtree. If one node is smaller and the other is larger, the root is the lowest common ancestor. 4. Implementing an algorithm to sort a stack in C++. Approach: use an auxiliary stack. While the original stack is not empty, pop an element, compare it with the top of the auxiliary stack, and insert it in the correct position. Steps: create an auxiliary stack, aux_stack. While the original stack is not empty, pop an element from the original stack, call it temp. While aux_stack is not empty and the top of aux_stack is greater than temp, pop from aux_stack and push it to the original stack. Push temp into aux_stack. aux_stack now contains the sorted elements. 5. Finding the kth smallest element in a binary search tree. Approach: perform an in-order traversal of the tree and keep track of the number of elements visited. When the count is equal to k, return the node. Steps: initialize a counter count to 0. Traverse the tree in order, left root right. Increment count each time a node is visited. When count equals k, return the node. Note: these are general approaches and might need adjustments based on specific implementations or additional requirements.